Alright everyone, welcome to my vodcast for projectile motion. Right here I have a picture of the problem I found in the textbook that was the simplest because I figured if I could show you the simple way, you should be able to figure out the harder way because I do all the steps for it. I'll let you read that. At the bottom I have our givens, our V0 of 20 meters per second at an angle of 60 degrees, and at the point of explosion your velocity in the y direction is 0 meters per second because it's at the top of the arc. And here I split up the vector of V0 into V0 of x and V0 of y. Obviously it's your Pythagorean theorem, pretty simple. And at the bottom right I've put out a diagram to show where I split the two separate projectile motion equations and charts, one before the split and one after the split, to find the total distance in the x direction. Before the explosion we have all these variables, V0 in the x direction of 10 meters per second, final is the same, the D0 is 0 meters because it starts at the origin. The d final is what we were trying to find. The acceleration is 0 meters per second and time is unknown. V0 in the y direction is 20 sine 60 meters per second. Our v final is 0 meters per second because we are stopping at the top of the arc. We are ending at the explosion for this projectile motion section of the equation. Our d0 is 0 meters. Our d final is unknown. Our acceleration, as always, is negative 9.8 meters per second squared. And our time is unknown. Because we only know a few variables in the x direction, we're going to start in the y direction. As you can see here, I plugged in a v final of 0, a v0 of 20 sine 60, an acceleration of negative 9.8, and a time of t. Simplify for t. Leave the number in your calculator so that you still have all the decimal places and you won't lose your accuracy. Alright, we're going to take the time and transfer it over to the x direction. We have a d initial in the x direction of 0, a v0 of 10. The time is that big long decimal. And then we have 0 for the last part of the equation because there is no acceleration, so that cancels it all out. We have a distance final of 17.655, etc. Leave that as a decimal because you will need it later. Do not round it off. Alright, because I'm doing a very simple problem, I'm going to work it the full length even though there's a shortcut. We are stopping at the top of the arc. You know that the time it takes to get up to the top is the exact same as the time it takes to get down. But assuming that some people don't know this, we're going to work it the long way. So you will need your y direction d final. So we just plug all the numbers in and you get d final of 15.2905, etc. Again, you're going to need to keep all the decimal places because this is not your final number. So don't round off on this. And you're going to need the d final in the x direction because that is part of the solution. So because momentum is conserved, makes this problem significantly easier to work because you can actually find the velocity before and after the explosion. So we have the two parts as a whole as m1 and m2 put together times v0, 10 meters per second in the x direction, and then that is equal to m1 times v final in the x direction plus m2 times v final in the x direction. One piece falls flat to the ground, so it has no v final in the x direction, so that becomes 0. And our m's cancel out, and we are left with 2 v0 in the x direction is equal to v final in the x direction. As said before, v0 in the x direction is 10 meters per second. We have a v final of 20 meters per second in the x direction. And as you can see here, we're post-explosion, so now we have to find the distance final in the x direction after the explosion. I have also plugged in the d0 of approximately 15.29052 meters in the y direction. Alright, so again we're going to work another projectile motion chart in the x and y direction. Plug in all the numbers, and you simplify it down, and you're able to find time it takes to reach the top of the arc. However, if you're working another problem that does not split the pieces at the top of the arc, you will be able to use the same equation to find your time it takes to fall from your position in the air. And we plug the numbers in, get a D final of 35.3119, etc. And finally, we take the pre-explosion and the post-explosion as shown in my diagram, and we add them together, and we get D final total is approximately 53 meters. Just follow all the steps. You can use your own numbers in the variable places. I find that this helps a lot because I had a lot of trouble with projectile motion myself. After doing this vodcast, I feel like I have a firm grasp on the concept. So I hope you do too. Thanks for watching, and I'm signing off.